Hey everyone, I'm Chelsea Ryan, and this is my presentation on constructivism and technology. So what is constructivism? In psychology, constructivists believe people actively construct their knowledge and meaning from their experiences. These could be individual, emotional, social experiences. So people aren't blank slates, they bring these experiences and personal factors to every situation. Further, mental development derives from a child's actions on the environment, so they're constantly making hypotheses and experimenting on those hypotheses, and that's an important part of early cognitive development. So we're going to look at two main constructivist approaches. The first one is cognitive constructivism, whose theory is by Piaget, emphasizes the importance the mind plays in learning. The second is social constructivism, whose theory is by Vygotsky, which focuses on the interaction between the environment and the learners. John Piaget's cognitive theory includes three components: schemas, assimilation and adaptation, and the stages of cognitive development. We are going to look at the first two. So what is a schema? A schema is the basic building blocks of the cognitive model that enable us to create a mental representation of the world. So a baby's favorite schema, same as my daughter's, is taking a toy and banging it off of a surface. Now, if a baby encounters a new toy, they still grab that toy and they bang it off of a surface. That's called assimilation. They're using an existing schema to cope with a new object or situation. For example, the toy that we're talking about. Now, if I give my daughter or baby an egg, and they go to bang that egg off the surface, it's going to break. Now, this doesn't fit their existing schema, so we have to go through accommodation, where we need to alter the existing schema to cope with the new situation. So, usually, we are in a state of equilibrium. Now, when we encounter a new situation, such as the baby breaking the egg, we're frustrated, and we are constantly striving for balance. So we're now in a state of disequilibrium. And we must accommodate, so change our existing schema to fit this new information. And this is how intellectual growth actually occurs. So once we've accommodated this new information, we now have a schema and we can assimilate things into it again. Lev Vygotsky's theory stresses the importance of social interactions and the development of cognition, and he believed community and environment play a crucial role in the process of creating meaning and knowledge. The two main principles of Vygotsky's work are the MKO, so that's someone or something who has a better understanding than the learner. MKOs are guides or facilitators, and they help the learner through the learning process. Second is the zone of proximal development. This relates to what a child can achieve independently or from the guidance of the MKO. So there are things the learner can do on their own, and then there are things the learner can do with a little bit of help. So this is called the zone of proximal development. This is where the MKO comes into play, and they help the learner get to the next level of learning new skills and higher intellectual development. So constructivist theory in education. Powell and Kalina 2009 say, in order to ensure an effective constructivist environment, teachers need to learn teaching strategies or activities that employ the theories of both Piaget and Vygotsky when assigning tasks or imparting information. So what two pieces of information are we going to take from these and apply to this lesson here? So from Piaget, we're taking students and putting them into situations where things do not operate in the context that they know, and they must accommodate and reframe the expectations within the outcomes. The thing to note about this is, in order for the process of assimilation and accommodation to be effective, we need an active learner, not a passive learner, because problem-solving skills are difficult to teach and they must be discovered. From Vygotsky, we're taking scaffolding and social interaction leads to more effective learning and internalization. And cooperative learning is part of creating a social constructivist classroom, and students should not only work with teachers one-on-one, but they should work with other students. When I think about a constructivist learning environment, I imagine things being a little chaotic, but hopefully what we're going to learn is things can be a little bit more structured than that. So what is a constructivist learning environment? Knowledge under constructivism is not seen as a commodity to be transferred from expert to learner. What it is it encourages exploration and interdisciplinary approaches. Learning is an active, reflective, and social process. Learning involves social negotiation, and knowledge is socially constructed. Further, it involves cultural and individual processes. New knowledge must be continually linked to old knowledge. Teachers are the guides and facilitators, not the instructors. The problems are real world, and the tasks are relevant, realistic, and authentic. Students should have ownership of their learning. Teachers and students must develop trust and openness in order for a constructivist learning environment to be successful. We must also recognize students learn in multiple ways, and we should provide multiple interpretations and expressions for students to exemplify their learning. As well, we must provide multiple perspectives and representations of the content. Learning is transferable, so the problem-solving skills and organizational skills learned can be used in multiple settings. We're focusing on the process of learning here, not the end product. So we're continually doing formative assessment, and this formative assessment informs our future exploration. And so ultimately, the students will begin to formulate their own questions and develop methods to solve their own problems and questions, which will help us reach the highest level of Bloom's taxonomy. Constructivist classroom applications include project-based, problem-based discovery learning, as well as apprenticeship, scaffolding, and everything else on this list. Current research suggests the constructivist paradigm is important for successful technology integration. Further research suggests the use of the internet in order to facilitate a successful constructivist learning environment. The use of the internet provides a nearly infinite variety of topics, adding flexibility to a task, and enables multiple multimedia representations for students to exemplify their learning. So, these constructivist tasks on the internet could include virtual field trips or virtual worlds, virtual reality, simulations, wikis, blogs, instant messaging, and social media, or web quests and jigsaw activities. And we're going to take a deeper look here at web quests. So what is a web quest? Web quest is a term created by Bernie Dodge in 1977, and a lot of research has been done by Dr. David Jonasson on web quests and the constructivist classroom. So Salsevich from 2007 says the use of a web quest incorporates not only technology, but also internet skills, cooperative learning, discovery learning, constructivism, and a high level of student engagement. These problem-based learning activities are engaging and foster 21st century skills. So web quests are structured in-depth internet research projects on a particular outcome or topic. They should be real-world. They should also be collaborative in order to align with Vygotsky's version of constructivism. They should also focus on local issues, prices, culture, and history. And they are most effective when students possess basic knowledge or skills on a topic, so we're forcing students into this state of disequilibrium, finding this new information, and they have to accommodate into their existing schemas. These are web quest characteristics based off of research, so they can be utilized at any level and are typically interdisciplinary. They can be open or direct. They could range from one class to months long. So Watson suggests 1 week or longer in order to provide an in-depth analysis on a concept. They can be collaborative or individual. They offer a different and more dynamic approach to teaching the values of research and time management. They should end up increasing students' problem-solving skills, upper cognitive thinking, and creativeness. They also allow students to learn in accordance with their own learning style, enabling web quests to be an effective teaching and learning tool. And the best part of all, there are a ton of web quests already made out there ready for you to use. Web quests are broken down in the following way. There's an introduction, the task is also introduced, the process, evaluation, and conclusion. So I googled a mathematics web quest because that's what I teach. So if you can see along the side here, the students can just click through here depending on what point they're at. So for this particular web quest, the introduction says, have you ever been haunted by the mathematics monster? So what's the task? We have to go defeat the quadratic math monster. So then students can pick from the following roles in the process stage. There are 4 different roles in this particular web quest. You could be a mathematical historian, mathematician 1, 2, or the real life investigator. Now, every single person here has a certain amount of things that they need to go find and answer using the internet. So everyone has a different role. They have to go answer all these questions using the internet. And then we come back and we share our information. And so we're really going to become the teachers of what we just learned through what we found on the internet to our classmates. And then there's always some sort of final project. So depending on what you wanted to do, it could be different. But for this one, you can do a plot chart. You can write a script. There's also a ton of things you can do. And then it also gives the students how they will be evaluated. And the end, well, you ended up defeating the monster. So it's always kind of a role-playing game for the students. We're going to take a quick look at the current academic research on web quests. So all of these research studies concluded web quests have a positive effect on students' motivation to learn at all ages. Salsevich 2007 states, incorporating computer technology into the classroom through the use of WebQuest improves the chances for successful learning. And these two research studies found that the students stated the animations, roles, and stories made WebQuest more attractive compared to the traditional way of teaching. Halat 2013 disclosed according to students, WebQuest had more pictures and figures in comparison to the textbook, which helps students remember information better. And this research study from 2016 revealed many pre-service teachers, even with computing backgrounds, had not encountered WebQuests. And with the proper learning opportunities, pre-service teachers were eager to create and implement their own WebQuests. There's a lot of other research out there. There's also a little bit of negative research on WebQuests. If you want to take a deeper look at all of that, please check out my PowerPoint that I posted. That's everything. The discussion questions will be posted on the forum. Thanks for listening. Have a good one.